Handling exceptions in Lambda expressions within Java streams can be tricky because Lambda expressions do not naturally support checked exceptions. However, with a structured approach, you can gracefully manage exceptions and maintain the functional style of streams. Let's break down how to handle exceptions in Lambda expressions within a stream pipeline step by step. First, understanding the problem. Java Lambda expressions do not allow checked exceptions to be thrown directly. For example, if you handling exceptions in Lambda expressions within Java streams can be tricky because Lambda expressions do not naturally support checked exceptions. However, with a structured approach, you can gracefully manage exceptions and maintain the functional style of streams. Let's break down how to handle exceptions in Lambda expressions within a stream pipeline, step by step. First, understanding the problem. Java Lambda expressions do not allow checked exceptions to be thrown directly. For example, if you have a Lambda that calls a method which throws a checked exception, you must handle it within the Lambda. This can lead to verbose and less readable code if not done carefully. We will discuss step-by-step solution. Step 1. Define the problem. Suppose you have a list of strings representing file paths, and you want to read the contents of each file using a stream. The Files.readAllLines method throws an I/O exception, which is a checked exception. Step 2. Create a utility method. To handle exceptions, you can create a utility method that wraps the Lambda expression. This method will handle the exception and return an appropriate result, such as an optional or a default value.
Let's break down the code. Class declaration. This line defines a public class named exception wrapper. A class is a blueprint for creating objects in Java. Generic method declaration. This line declares a static method named wrap. It uses generics to allow the method to accept any types for T, input type, and R, output type. Parameters. The method takes one parameter of type checked function, which is a custom functional interface defined later in the code. This interface allows for a function that can throw exceptions. Lambda expression. This line begins a Lambda expression, which is a concise way to represent an anonymous function. Here, T is the input parameter for the Lambda. Try block. This line starts a try block, which is used to wrap code that might throw an exception. Function application. This line attempts to call the apply method of the function parameter, passing T as an argument. If this method call succeeds, it returns the result. Catch block. This line begins a catch block that catches any exception that might be thrown in the try block. The caught exception is referenced by the variable e. Logging the exception. This line prints an error message to the standard error output. It concatenates the string exception with the message from the caught exception e.getMessage method. Return null. This line returns null if an exception occurs. Alternatively, you could throw a runtime exception here to indicate failure. End of Lambda expression. This closes the Lambda expression and the method. End of class. This closes the exception wrapper class definition. Functional interface declaration. This defines a custom functional interface named checked function. It declares a method apply that takes an argument of type T and returns a result of type R. It also specifies that this method can throw an exception. The exception wrapper class and its wrap method provide a way to handle exceptions in Lambda expressions. The wrap method allows you to pass a function that may throw checked exceptions and handles those exceptions gracefully, either logging them or returning a default value. We will see the utilization of this wrapper in main class on. This declares a public class named stream exception handling. The main method is the entry point of the program. It's where the program starts executing. This line creates a list of file paths containing file1.txt, file2.txt, and file3.txt. Begins creating a stream from the file paths list. A stream is a sequence of elements that supports various operations to process data. The map function transforms each file path into its corresponding file contents. Exception wrapper.wrap is used to handle exceptions that may occur during Files.readAllLines, which reads all lines from a file. This line filters out any null values from the stream. If an exception occurred while reading a file, it would result in a null. Collects the results into a list of lists of strings. Each inner list contains the lines of a file. Iterates over each list of file contents and prints it to the console. This program reads the contents of multiple text files specified in file paths. It uses Java streams to process each file path, attempting to read the file contents. If reading a file causes an exception, it is handled gracefully by wrapping the operation, and null values are filtered out. Finally, the program prints the contents of successfully read files to the console. This approach allows for clean exception handling within a stream pipeline. Handling exceptions in Lambda expressions within streams requires careful design to maintain code readability and functionality. By creating utility methods like wrap, you can effectively manage exceptions without cluttering your stream pipeline with try-catch blocks. This approach keeps your code clean and your stream operations functional.